Okay, let's do a little bit on redox first. I have two really fun ones. You get to choose your own adventure here. I'll do a redox, and I'll do a net ionic, and we'll kind of stop there, I think. And if you want to ask me more specifics, we can. That's totally fine. Okay. You can choose this one or this one. They're both kind of equally hard. I would expect both of these to have about the same mean per problem. I know the top one looks easier, but you know. So you get to vote in about 5 seconds. You're going to pick top or bottom, okay, by a show of hands. Who wants the top one? Raise your hand. Okay, who wants the bottom one? Oh, that's interesting. Most quarters have picked the top one. So you are a variant in your own right. Okay, we're going to do the bottom one. I would try the top one just for fun as like a practice problem, see if you can do it. It was H2 plus O2 goes to water. Okay, so how do we do this? Put likes with likes, Cr2, O7 2 minus, goes to Cr3 plus, and then put the one with carbons together, C2H5OH, goes to CO2. Okay, so we split likes and likes. Everyone has 4 steps. So let's do the top one. Step 1, you balance whatever's not oxygen or hydrogen, that's chromium. I need 2 on each side. Step 2, I balance the oxygens with water. There's 7 on the left, I need 7 on the right. Okay. Step 3, I balance the hydrogens. I have 14 on the right, so I need 14 on the left. Okay. The last step, I need to balance the charge. What's the overall charge on the right-hand side? Right now. 6. Left-hand side? 12. So I'm going to add the electrons which side, right or left? Left, and how many? You want 6? Let's see if that works. 14 minus 2 is 12, minus 6 is 6, and the right hand is 6. That works. Okay, next one. Step 1, balance whatever's not oxygen or hydrogen. That's carbon. I need 2 over here to balance the 2 on the left-hand side. Step 2, I need to balance the oxygens. There's 4 on the right, 1 on the left. So on the left-hand side, looks like I need 3 waters. Okay? Okay, now what? Hydrogens. Balance hydrogens with H+. On the right-hand side, there's how many hydrogens right now?
Wait, no.
12. Does that look good? 12. So I need to add 12 H+ over here. All right, and then the electrons, it looks like I just straight up need 12 to make it 0 or the same charge on each side. Okay, let's double check my math here. Looks good. I think it looks good. All right, now let's go back to my black pen here. I'll move this out of the way. I don't need it anymore. Oh, by the way, I should figure out which one was the oxidation, which one was the reduction. Let's get my other. I'll give you a second while I get the color pen I'm looking for here. I need the oxidation reduction. Yeah. Okay. Which one was the top one? Is it oxidation or reduction? Okay. Let's just double check to see it right. This is +3. What was the charge of this chromium right there? The oxygen is -2, so that means there's -14 for the oxygen. So I need chromium to be 12 minus 14. So it has to be what? +6. So it's going from 6 to 3. Hexavalent chromium is carcinogenic, by the way. Don't eat it. 3 minus 2, or 6 to 3, that was reduced. By default, this has to be the oxidation. Let's just double check. Carbon dioxide has what charge on the carbon? +4. And what would we get for this carbon over here? This would have been +4. What's this carbon right there? +2. Let's see if that works. The carbon, there's 2 of them at +2. That makes it +4. There's 6 hydrogens at +1. No, I don't know if it's +2, y'all. Yeah, it's -2. Okay, that should do it. Okay, either way it's oxidized, it went up in oxidation state. Common mistake, a very, very common mistake is people to switch these two. Okay. All right, I'm going to multiply the top reaction by 2, the bottom by 1, and that's because this 6 and 12 have to cancel. So I need twice the top. All right, let's write this craziness out. 28, H plus 2, Cr2O7, 2 minus, plus 3, H2O, plus C2H5OH. That's all the reactants. Products now. Not 2. 4, Cr3 plus 14, H2O, plus 2 CO2, this is awesome, plus 12 H plus. Okay, that looks like I can do a little bit of simplification. This 12 cancels with this 28 to be 16. What else cancels? The water, yeah. To make 11 net. Okay, is that the answer I'm looking for if I write it nicely? No, what do I need to do? Yeah, ask for basic solution. So I find the H plus, which is over here, and I add the same number of hydroxides to each side. So there's 16 H plus, I need to add 16 hydroxides to each side. Okay, so I do that. That makes how many waters on the left? Yeah, H plus and OH minus makes 16 waters. Plus 2 dichromates, ions, plus, let's see, C2H5OH. Right-hand side, 4 chromium 3 plus 11, H2O, plus 2 CO2, plus 16 hydroxides. Does anything cancel? Are we good? The water, the waters cancel to leave 5 here. And it looks like I can fill in the blanks now. 5 waters plus 2 Cr2O7, 2 minus, plus C2H5OH goes to 4 chromium 3 ions, plus 2 carbon dioxides, plus 16 OH minus. There's my final answer in basic solution. I could put my state symbols in. Water is a liquid. Anything with a charge is aqueous. You might not have known this, but I was given in the problem. C2H5OH, it's a liquid. That's ethanol. CO2 is a gas, and here's another aqueous. That would be my final answer. Oops, I can't see it. There you go. Cool, that was a fun one. I would consider that like a medium difficult problem. Okay, there was one last thing we want to do, and that's the net ionic equations. I think I have some examples of those actually. Yeah, let's do the second one. If you want for fun, you can do the first one with your family at home or your dorm mate or whatever, but we're going to do the second one, okay? This is a very typical, definitely test level question. Second one, silver has what charge? +1, and a nitrate is -1, so there's silver nitrate. Plus sodium is +1. What's chromate charge? -2 minus, so I need 2 sodiums. This is what kind of reaction? Double replacement. So the silver goes with the chromate. Remember, I need 2 silvers because they're +1. And the sodium goes with the nitrate. Okay, there's my reaction. Let's double check that it's balanced. So I need a 2 here and a 2 here. That's step 1 of my net ionic equation. Step 2, grab your solubility rules. So I'm going to move over here, find my solubility rules. You can look in your reader or wherever you have those. Okay. I know that this first one is aqueous because
Nitrate.
all nitrates are aqueous. So let's fill in a couple blanks here. This is AQ and this is AQ because I know all nitrates are aqueous. I know that this one's aqueous. Why is that? Group 1. Yeah, bullet 1 means group 1s are aqueous. How about this one? That's a solid because all chromates are solids. Okay? So this is what kind of reaction it is. Double replacement is also called precipitation reaction. Yeah, because it forms a precipitate or a solid. All right, now I want to underline it. Maybe I should say this way. Which of these 4, is there any that's not a strong electrolyte? Just a solid. So let's underline the rest of them here. The rest of them are not strong. The solids not, but the aqueous are. Why? Because the aqueous ionic is always a good electrolyte. So we've got 2, now write these separately, 2 Ags and 2 nitrates here. We've got 2 sodiums and a chromate here. We've got 2 sodiums and 2 nitrates here. You're going to see that some stuff cancels. The nitrates will cancel and the sodiums will cancel. So let's see what's left. We've got 2 Ag plus aqueous plus CrO4 2 minus aqueous goes to a silver 1 chromate. That'd be my net ionic equation.